Hi to everyone. Today we are going to see the topic that is two-dimensional random variable. We already know that there is a two type of random variables there. One is discrete random variable and other one is continuous random variable. So in that we are going to see the problems. The problem number one is the joint probability mass function. If they mention the probability mass function is obviously it is discrete random variable. Here we are going to see two-dimensional random variable, then it is two-dimensional discrete random variable. So problem number one is the joint probability mass function of x comma y is given by p of x comma y is equal to k of 2x plus 3y. This is the problem. And x tends to 0 to 2 and y from 1 to 3. Find k and all the marginal and conditional probability distribution. Also, find the probability distribution of x plus y. So here we must find k value and marginal distribution and conditional probability distribution and also distribution of x plus y. So we must frame a table that is x from 0, 1, 2 and y values 1, 2, 3. We substitute the x and y value in the function of p of x is comma y is equal to k of 2x plus 3y. Suppose if take x is equal to 0 and y is equal to 1, here put x is equal to 0, then is obviously 0, and y is equal to 1, then it is 3, and k is a constant, then it is a 3k. Similarly, put x is equal to 0 and y is equal to 2, then it is 6k. Put x is equal to 0 and y is equal to 3, then it is 9k. Similarly, x is equal to 1 and put the y values, that is 1, 2, 3. Similarly, put x is equal to 2 and y value is 1, 2, 3. And we must frame the table. So now our first distribution is find k value. So we know that the total probability value is 1. Here it's a two-dimensional random variable. Then we take two summations. So p of x comma y is equal to 1. So sum of all probability value is 1. We know that already. So the values of k is 3k, 5k, 7k, 6k, 8k, 10k, plus 9k, 11k, and 13k is equal to 1. We simplify the left-hand side, we will get 72k is equal to 1. Obviously, k is equal to 1 by 72. So, we substitute the k values in table number 1. So, here x is equal to 0, 1, 2, and y is equal to 1, 2, 3. We substitute the k values 3 by 72, 5 by 72, 7 by 72, and 6 by 72, 8 by 72, 10 by 72, and 9 by 72, 11 by 72, 13 by 72. If we add, we will get the P of y value. So here adding the column wise, we will get the P of x of x value. So 0 and corresponding value is 18 by 72. If we take 1, the corresponding value is 24 by 72. If we take 2, the corresponding value 30 by 72. Similarly, 1 is corresponding value is 15 by 72. The 2 is corresponding value is 24 by 72. And 3 is 33 by 72. So substitute this value and simplify this value, we will get this table. So our second subdivision is find the marginal distribution of x and marginal distribution of y. It's nothing but x value, I'll note that 0, 1, 2. That's corresponding 0 and 1 and 2 value is P of x comma P of x value, that is marginal distribution of x. Similarly, marginal distribution of y is nothing but 1, 2, 3, and P of y odd value is nothing but, that is row wise the value 15 by 72, 24 by 72, and 33 by 72. So this is the margin distribution of x and marginal distribution of y value. Next, we are going to see conditional probability. So conditional distribution of x, we fix the x value and changing the y values. So we fix first x is equal to, we fix the x value and substitute y is equal to 1, and we will get the values of 3 by 15, 5 by 15, and 7 by 15. Next, we fix the x value and changing the y is equal to 2. Then we will get the values of 6 by 24, 8 by 24, and 10 by 24. Similarly, we're changing y is equal to 3 and the values of 9 by 33, 11 by 33, and 13 by 33. Now, here fix the y value and changing the x values. So, first x is equal to 0, and we will get the values of 3 by 18, 6 by 18, and 9 by 18. And another one, changing x value here, that is 1, and we will get the values of 5 by 24, 8 by 24, and 11 by 24. Similarly, we changing x is equal to 2, and we get the values of 7 by 30, 10 by 30, and 13 by 33. So this is our third subdivision of conditional distribution. Next, we see the probability distribution z is equal to x plus y. So we simplify and we will get the outcomes are 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. So the outcomes of 0, 1. So we must see the table. Here x is equal to 0 and y is equal to 1. So 0, 1. So the 0, 1 values is, here x is equal to 0 and y is equal to 1. Then the 0, 1 value is 3 by 72. Here we get the 3 by 72. Similarly, next 0, 2, 1, 1. Here 0 is x and y is 2. Here 1, 1 is x is equal to 1, y is equal to 1. We adding the values of 0, 2, 1, 1, and we will get 11 by 72. Similarly, 0, 3, 1, 2, 2, 1, we adding the three values and we will get 24 by 72. And the next one is 1, 3, 2, 2. If you're finding the 1, 3 values and 2, 2 values, adding the two values and we will get 21 by 72. Similarly, 2, 3. Here x is equal to 2, y is equal to 3. We must see the values in the table. That values is 13 by 72. So this is the solution of our first problem. Next, we're going to see the problem number 2, that is joint probability density function. Above problem is probability mass function, that is discrete case. Here mentioned probability density function, then it is a continuous case. So our problem number 2 is the joint probability density function of a bivariate random variable x, y is f of x, y of x, f of x, y is equal to k of x plus y. The limit value is 0 to 2 and 0 to 2, where k is a constant. So we must find The first subdivision is find k value. Our second subdivision is find the marginal density function of x and y. The third one is are x comma and x and y are independent. And the last one, find f of y divides x and f of x divides y. So first we are going to see our first subdivision, find k value. The given joint probability density function of a bivariate random variable x comma y is f of x comma y is equal to k of x plus y. The limit value of x and y is there. So the limit value is minus infinity to infinity, but our given limit is 0 to 2 and 0 to 2. So we taking the limit value 0 to 2 and the function k of x plus y. Here k is a constant. Then we taking the k outside. The limit values is 0, 2 and 0, 2. So integrating with respect to x, and we will get x squared by 2 plus x comma y, x into y. So substituting upper limit and lower limit, and we will get the values of 2 plus 2y is equal to dy. Here 1 is total probability value is 1, then we taking y equal to 1. So next we are integrating with respect to y, then it is 2y plus y square. Now substituting the upper limit and lower limit value, then we will get the 8k is equal to 1, then k is equal to 1 by 8. Our k value is now 1 by 8. Next, we are going to see the second subdivision, that is marginal of probability density function of x is given by f of x is equal to minus infinity infinity f of x comma y into dy. Here f of x comma y value is 1 by 8 and x plus y, the limit value is 0 to 2. Obviously the x limit value is 0 to 2. So we must integrating with respect to dy, then it is xy plus y square by 2. Now substituting upper limit 2 and lower limit 0, and we will get 1 plus x by 4. Then the marginal distribution, the marginal probability distribution of x is f of x is equal to x plus 1 by 4. The limit tends to 0 to 2 and 0 is otherwise. Similarly, now we see the marginal PDF of y. Now we take f of y is equal to minus infinity to infinity, f of x comma y. We already know that k value is 1 by 8. Then the k is a constant. Then we taking the outside, then 1 by 8. The x limit value is 0 to 2 and x plus y into dx. Now integrating with respect to dx, at x squared by 2 plus yx. Now substituting upper limit, lower limit value, that is 2 plus 2y, and simplify this, we will get y plus 1 by 4. Now the marginal PDF of y is y plus 1 by 4. There f of x value is x plus 1 by 4. Here f of y value is y plus 1 by 4. Next, we are going to see the subdivision number 3, check the independent values. How to check independent values is the formula of f of x into f of y is equal to f of x comma y. So we are taking left hand side and right hand side. If it is equal, then it is independent. If not is equal, then it is not independent. Here our case is not equal, then it is x and y are not independent. Next we see conditional probability of f of y divides x and f of x divides y. First we see f of y divides x. So f of y given x is equal to f of x comma y by f of x. Here f of x comma y value is 1 by 8 of x plus y by f of x is 1 by 4 of x plus 1. Simplify this, we will get the values of 1 by 2 of x plus y by x plus 1. So f of y divides x is equal to 1 by 2 of x plus y by x plus 1, and limits tends to 0 to 2 and y is 0 to 2. So the last subdivision is probability of 0 to 1 by 2 divides x is equal to 1. Here x value is 1. So substituting x values in above, we find the values of 1 by 2 x plus y by x plus 1, and we will get the values of 1 by y by 2. And limit value is 0 to 1 by 2. Y limit value is 0 to 1 by 2. Then we take 0 to 1 by 2. Here 1 by 2 is a constant. Then we taking outside. Then substitute x values here, and we will get the values of 1 plus y by 2. So integrating this function, and we will get the values of 5 by 32. Next, we are going to see the problem number 3. If x and y are two random variables having joint probability density function, here the mentioned probability density function, then it is a continuous random variable. The function is f of x comma y is equal to 1 by 8 of 6 minus x minus y. The limit from 0 to 2 and y limit is 0 to 4. We must find the subdivisions. The subdivision number 1 is probability of x less than 1 intersection y less than 3. And second subdivision is probability of x plus y less than 3. And third subdivision is probability of x less than 1 given y less than 3. So the subdivision number 1, that is probability of x less than 1 intersection y less than 3. Here the limit value is minus infinity to 3 and x limit is minus infinity to 1. The function is f of x comma y dx into dy. So our given function is 1 by 8 of 6 minus x minus y. So according our limit value is changed to 0 to 1 and 2 to 3. Now integrating this with respect to x is 6x minus x squared by 2 minus xy. Now substitute upper limit x is equal to 1 and lower limit 0, and we will get the values of 11 by 2 minus y. Now integrating with respect to y is 11y by 2 minus y squared by 2. Now substitute upper limit 3 and lower limit 2, and we will get the values of 3 by 8. So subdivision number 2 is probability of x plus y less than 3 is equal to, so our limit value is 0 to 1, that is y limit, and x limit is 2 to 3 minus x. And our function is 1 by 8 of 6 minus x minus y. Now integrating this function with respect to y, then 6y minus xy minus y squared by 2. Now substitute upper limit 3 minus x and lower limit 2. Then we will get the function 6 into 3 minus x into 3 minus x minus 3 minus x squared by 2 minus lower limit 2. Substituting 2 value is 12 minus 2x minus 2. So simplify these equations and we will get the values of the particular values. Now integrating with respect to x. So before that, We simplify this and we will get the values of 7 by 2 minus 4x by 4x plus x squared by 2. Now this integrating with respect to x, that is 7x by 2 minus 4x squared by 2 plus x cubed by 6. Now substitute upper limit 1 and lower limit 0. So here constant value is 1 by 8. And if substituting the limit values, we will get 7 by 2 minus 2 plus 1 by 6. So simplify this, we will get the values of 21 minus 12 plus 1 by 6. And simplify this, that is 10 by 6. And multiply this, we will get the values of 5 by 24. This is the answer of subdivision number 2. Next, we see subdivision number 3, that is conditional probability. Probability of x less than 1 is given y less than 3. So, x less than 1, it means probability of x less than 1 intersection y less than 3 and probability of y less than 3. Then the marginal density function of y is f of y is equal to, here less than 1 means obviously it is 0. Here less than 3 means obviously it is 2. Then it is limit value 0 to 2. And f of x comma y, our function is 1 by 8 of 6 minus x minus y. So 1 by 8 is a constant. And integrating, we will get the values 6x minus x squared by 2 minus yx. So substituting upper limit, lower limit values 2 and 0. And the values is 12 minus 2 minus y. So simplify this, we will get 5 minus y by 2. Sorry, 4. So our problem is probability of x less than 1 divides y less than 3. So our function is 1 by 8 of 6 minus x minus y in dx dy by integral 2 to 3 and f of y value. Our f of y value is 5 minus y by 4. So substituting 5 minus y by 4 here. So our numerator value is 3 by 8 and denominator is 5 minus 4 by 4. The condition is the limit value is 2 to 3. Then 3 by 8 by 4, 3 by 8 by 5 y minus y square by 2. If integrating with respect to y, the values is 5y minus y square by 2. And our limit value is 2 to 3. Substituting upper limit, lower limit, we will get the values of 3 by 5. Next, we are going to see one other important problem. That is problem number 5. The joint probability mass function of a bivariate discrete random variable x comma y is given by the table. Our x is value is 1, 2, 3 and y value is 1, 2 and the corresponding values 0.1, 0.1, 0.2 and 0.2, 0.3 and 0.1. Our question is to find a marginal probability mass function of x and y. And the conditional distribution of x given y is equal to 1 and p of x plus y less than 4. So the solution is the joint probability mass function of x comma y is the given table is, so we adding the row value and we will get 0.4, 0.6. And if adding the column value, we will get 0.3, 0.4 and 0.3. Then from the definition of marginal probability function, p of x is equal to summation of p of x comma y. We fix the x value. Here x is equal to 1 and we will get the values of 0.3. Next, we fix the x is equal to, so probability of x is equal to, and the values is 0.4. Next, we fix the x value 3, and we will get the values that is 0.3. So the final answer is the marginal probability mass function of x is the p of x is equal to 0.3 when x is equal to 1, 0.4 when x is equal to 2, and 0.3 when x is equal to 3. So next, the marginal probability function of p of y is equal to summation of p of x comma y. Now here fix the y values. When y is equal to 1, the corresponding probability of y is equal to 1 value is 0.4. Similarly, we fix the y value 2, and the value is, the answer is 0.6. Therefore, the marginal probability mass function of y is 0.4 when y is equal to 1 and 0.6 when y is equal to 2. Our second subdivision is the conditional distribution. So P of x divides y. Therefore, P of x is equal to x intersection y is equal to 1 of P of y is equal to 1. So we're taking the corresponding values of P of 1 comma 1 by P of 1. So P of 1 comma 1 value is 0.1. P of 1 value is 0.4. We simplify this, we will get the values of 0.25. Similarly, we fix x is equal to 2, and P of x is equal to 2, it divides y is equal to 1, and the values is 0.25. Similarly, x is equal to 3, therefore P of 3 comma 1 value is 0.2, P of 1 comma 1 value is 0.4. This value is taken from the above table. So simplify, we cancel it, we simplify 0.2 by 0.4, we'll get the values of 0.5. Next, our third subdivision is P of x plus y less than 4. So its overall outcome of this, the P of 1 comma 1, 1 comma 2, and 2 comma 1. So probability of 1 comma 1, probability of 1 comma 2, probability of 2 comma 1. The corresponding values taken from the table. So P of 1 comma 1 value is 0.1. P of 1 comma 2 value is 0.1. P of 2 comma 1 value is 0.2. Therefore, the value is 0.4.